Hello everyone, welcome back. This is Engineer Hussein Mwasapi. Alright, so this is a continuation of our NQNS Physics exam revision. Alright, so before we begin, do not forget to like, subscribe, hit the notification bell icon, and share the video with one of your friends or something. Alright, so it reads to say an object moving along the x-axis in such a way that its displacement x is given by the expression. So the expression is saying x is equal to 30. So let's write this. X is equal to 30 plus 20t minus 15t squared, where x is in meters and t is in seconds. Find the expressions for the velocity v and the acceleration. All right, let's work on this guy. So one thing you should understand is that the approach we use in solving this question is calculus. Because when you differentiate, if you have position, so the displacement to say velocity and acceleration, differentiating the position gives you the velocity, and differentiating the velocity gives you the acceleration. And this is the position as a function of time, given as 30 plus 20t minus 15t squared. Therefore, if I want to find the expression for the velocity, so I'll start for v first. We know velocity is equivalent to the change, small change, or the change in the x over the change in the x over a period of time. So it's dx over dt, and differentiating what we have, which is the position function. The derivative of 30 is 0, derivative of 20t, using the power, that is, will be 20. Then derivative of minus 15t squared here will give us minus 30t, that is reducing the power by 1. So basically the expression will be 20 minus 30t, and this will be the expression for velocity. Now doing the same for the acceleration, we know acceleration is equal to the change in velocity over some time. What we'll do is to differentiate what we have here. So differentiating 20, that would be 0, differentiating minus 30t, that would be minus 30. And this will be our acceleration expression. I know it's supposed to be an expression, but differentiate, we're not really having those other variables. So minus 30 as a constant is our answer. That's why it was even literally like 2 marks. So the second question reads to say, find the value of the initial position and the initial velocity of the object. So the initial velocity and position. So the initial position, that's x at time 0. So that would be wherever there is in the original position function, wherever they still put 0, that would be 30 plus 20 times 0 minus 15 times 0 to give us the initial position at time 0 being what? 30 meters, and that's the initial position. And the initial velocity, we know that velocity as a function of time has been found here to be equivalent to 20 minus 30t. So v at the initial point, which is time 0, is equal to 20 minus 30 times 0. So v at time 0 is equal to 20. Now it's velocity, so it's going to be in meters per second. And that's how you go about solving this question. Alright, so if you have questions, you can shoot me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And let's strategize before becoming statistic. Let's try and push for that A+.